right, the first couple were similar, 1 and 2, so let's look at problem number 1 together. It tells us we're finding sine, cosine, and tangent for some different angles. We have right triangle ABC, where C is 90 degrees. All right, first mistake that I tend to see on these is people flipping their sides and putting them in the wrong spot. When they do that, where is side A? On the bottom. It goes across from angle A, so that's 1. Where is side B? Across from angle B. So I don't know side C. How can we find it? So 1 squared plus 2 squared equals C squared. So C turns out to be the square root of 5. So then, when I ask for sine of A, I didn't tell you the angle, we don't need it. Sine, SOHCAHTOA. If I'm viewing from angle A, this is my opposite, this is my hypotenuse, so that means this is the adjacent. So sine is opposite over hypotenuse, so 1 over the square root of 5. You can't leave a radical on the bottom, so that's radical 5 over 5. Cosine is adjacent over hypotenuse. So from angle A, my adjacent is 2, hypotenuse radical 5. So you get 2 radical 5 over 5. Tangent, opposite over adjacent, would be 1 over 2. Then I ask for the same things for angle B. I'm going to run out of room here. So what happens when I switch my viewpoint to angle B? Yeah. Now this is my opposite, and this is my adjacent. So from here, sine opposite over hypotenuse, so 2 over radical 5, or 2 radical 5 over 5. Cosine adjacent over hypotenuse, so 1 over radical 5, or radical 5 over 5. Tangent opposite over adjacent, so 2 over 1 is 2. Right, on these, I would expect you to use radical 5. Don't try to give me a decimal or anything like that. Go ahead and use that exact value. And then final answer, you always have to get the radical off the denominator. So question number 2 is just like that. Do I need to work out number 2? Okay. Number 3, we need to talk about. So our cofunctions. Remember, I always told you sine went with cosine. Secant went with cosecant. Tangent went with cotangent. But cofunctions are different than our reciprocals. When are cofunctions equal to one another? When their angles add up to 90. Okay, so when their angles are complementary. So to find this, the cofunction of sine is cosine. So to find my missing angle, I just have to do 90 minus 14. So we get 76 degrees. Those aren't necessarily hard questions, but it's something to remember because it doesn't pop up very often. So cofunctions are equal when their angles are complementary. All right, question number 4. I'm asking you to simplify these. So on the test, I would be checking for all of your exact values. When you see sine squared of 45 degrees, that means you're going to take the sine of 45 degrees and square it. I expect exact values, no decimals here. What is the sine of 45 degrees? How do we know that? The hand trick. Sine of 45, radical 2 over 2. Okay, plus the cosine of 30 squared. So 30 degrees, cosine's the square root of the bottom over 2, so radical 3 over 2. So if I square, the square root of 2 squared is 2 over 4. Square root of 3 squared would be 3 over 4. So you get 5 over 4. Number 5. What'd you guys get for that one? 2. Tangent of 45 degrees, square root of the top over square root of the bottom. Radical 2 over radical 2 is 1. Cotangent, you just flip it. So 1 plus 1 is 2. All right. 6 or 7, do you want me to work out either of those? Number 6, you should get 0. 7 should be 1/2. Okay. Let's talk about the calculator questions. On any calculator question, what do you have to do first? Yes, make sure it's in degree mode. If you are in the wrong mode, you will get every one of these wrong. Okay, then we have to know how to type it in. So if I have 24 degrees, 20 minutes, you push sign, you do 24 plus for the minutes, 20 over 60. All right, everybody try these so I make sure we're on the right track. Everybody pick up a calculator. Punch this in. All right, what did we get? Unless I specifically say on a problem to use significant digits on the test, then I just want the standard 3 or 4 decimal places on them. So the cosine of 37.8, you should be able to quickly punch that one in and you get 7902. All right, how do we do cotangent? 1 divided by tangent, and then in parentheses 71 plus 20 over 60. So we get 0.3378. All right, question 11 and 12 are different. What am I looking for on 11 and 12? The angle. If you want to move that sign to the other side, that's when you have to use the inverse. So anytime you're looking for that angle, that will be the inverse, that sine -1. So to type that in, you push second sine. This is an angle, so it's degrees. So 71.1735 degrees. All right, we don't have a secant button. A lot of people had trouble with this one yesterday because they were moving it over and then trying to do 1 divided by cosine inverse and getting errors on it. Before you can do anything, you have to rewrite this in terms of cosine. So that means cosine is 1 over 1.923. So to find the angle, we do cosine inverse of 1 over 1.923. And if you do that, again, it's an angle, so we get 58.664. Oops, I missed a 6. 3 6s and then a 4. All right. Can everybody use their calculator to evaluate this? There'll probably be one like number 12 on there, because that's something we've talked about a few times and it is a little bit tricky. You have to make sure and rewrite it. If it were secant or cosecant, cotangent, you rewrite it in sine, cosine, or tangent, and then evaluate. All right, then we got into the solving a triangle. So 13, 14, and 15 are all the same. Pick one. Which one do you want me to do? 14. Okay. So we have right triangle ABC. So I strongly recommend drawing a triangle. C is the right angle. Side B is 305. That's across from angle B. Angle B is 24.9 degrees. I have to find everything else. So what I'm missing right now, I don't have side A, I don't have side C, I also don't have angle A. Angle A is probably the easiest. Remember, the angles are the capital letters. How would I find angle A? And we get so angle A is 65.1 degrees. All right, to find the other things, let's set up a trig function. So, if I'm viewing from angle B, 305 is opposite, C is my hypotenuse, so that means A here is my adjacent. So if I'm looking for A, I need my adjacent, I have my opposite. What trig function involves opposite and adjacent? Tangent of angle B, so the tangent of 24.9 degrees, equals the opposite side, 305, over the adjacent side, A. Make sure on the test, I know it's tempting a lot, especially on these questions where it's all on your calculator, write out what you're doing so I know in case you make a mistake. To solve this, you would multiply over your A. So then to get A by itself, you just have 305 divided by the tangent of 24.9 degrees. So if we type that in, this one you get 657.0663. I didn't specify in the question to use significant digits, so that would be fine. If on the test I said significant digits, how many were given in the question? 3. So what would you call it? 657. So just make sure you can give me significant digits when I ask for it. All right, then how could I find side C? You have two options. You could do opposite over hypotenuse, so sine. Could you also do Pythagorean theorem at this point? Yeah. I don't care, but I do need you to show me the work because we talked about, especially with significant digits, depending on which way you solve it, the rounding may be slightly different, so I need to know how you're getting your answer. Just make sure you're showing me that. So if I do my trig function, I'd multiply by C and divide my sine. So we get 724.4039, or significant digits 724. All right. Do we need 13 or 15? Problem 13 is slightly different in that I gave you two sides. Do you guys know how to get your angle if you're looking for that? We don't have to do the whole question, but let's make sure we can find an angle. So side A, that would be down here, 68.0, so 3 significant digits. B is 104. If I wanted to angle A, what would I have to do? We can look from here. This is our opposite. This is the adjacent. So we could say tangent of angle A equals 68 over 104. Then, if you're trying to find A, we have to move tangent to the other side. What do we do? Inverse. The inverse gives you the angle. you do that, get 33.1785, or significant digits 33.2 degrees. Once you have angle A, how would you get angle B? Subtract from 90. How could you find side C? Pythagorean theorem or trig function once you found an angle. All right, do I need to finish that problem or can you handle that? Let's go to the next page. All right, all of these, I'm saying find the exact value. What does exact value mean? Radicals, not just a decimal. I would expect a little bit of work here. When I'm looking at 420, what would we have to do? Okay. So that gives us the tangent of 60 degrees. All right, that's just quadrant 1, so that's just our normal hand trick. Tangent of 60. So square root of the top over square root of the bottom, so radical 3 over radical 1 is radical 3. So the work I would expect to see on the test, I'd expect to see that you turned it into 60 degrees and you got your radical 3. Now, when I say something like 315, I can't just subtract 360 there. So what work do I want? Two things I asked you to write down on this. What quadrant is 315 in? And remember, we look at the quadrant so we know if it's positive or negative. In quadrant 4, cosine is positive, so that means sine is going to be negative. All right, reference angle. If you get stuck on this, draw yourself a picture. What we know is this is 315. I just need this part right here, so how do we get it? 360 minus 315 is 45. So I know it's negative. Now I'm just doing the sine of 45 degrees. So that's our hand trick. Sine, square root of the top, over 2. So negative radical 2 over 2. Okay, show me your quadrants and reference angles there. If I say negative 120, you could do quadrant and reference angle from here. A lot of times we would get a positive angle by first adding 360. So this is the cosecant of 240. What quadrant is 240 in? Okay. In quadrant 3, cosecant is the reciprocal of what? Sine. In quadrant 3, tangent is positive, so sine would be negative. All right, then reference angle. In quadrant 3, if this is 240, how do we get our reference angle? We subtract that 180. Remember, reference angle is just how far to the x-axis. If you're in doubt, draw yourself a picture, and I think you'll be able to figure it out. This thing was 240. We just want that part, so you subtract 180, and we get 60 degrees. Okay, so let's think about sine. The sine of 60 is radical 3 over 2. Cosecant would flip it, so 2 over radical 3. So get your radical off the bottom, so negative 2 radical 3 over 3. I'm going to go ahead and talk about number 19 also. So it's more of the same thing. If I put that one on the test, I'd probably make it worth at least 4 points because I'm going to give you a point for the tangent of 120, for the sine of 150, for the cosine of 180. So I'm expecting you to show me your work. Okay, I'm not asking you to plug these into a calculator. We are working them out. So, 2 tangent squared of 120. That means we're going to take the tangent of 120 and square it. What quadrant is 120 in? In quadrant 2, sine is positive, so tangent is negative. All right, reference angle, 180 minus 120. The tangent of 60, radical 3 over radical 1, is radical 3. Plus 3, sine of 150 squared. So 150 is in quadrant 2. In quadrant 2, sine is positive, so we're good there. Reference angle, 180 minus 150 is 30. What's the sine of 30? Minus the cosine of 180 squared. So a couple ways you can get cosine of 180. It's kind of like a reference angle of 0, except it's going to turn out to be negative, because we're over here. So if you wanted to think, what's the cosine of 0? So if I fold in my 0, radical 4 over 2, so 2 over 2 is 1, and since we're back here, it would be negative 1. Or you can go back to our x, y, and r trick from the last chapter. Cosine is x over r, so negative 1 over 1 is 1. So then you just work this out, so you get 2 times 3 plus 3 times 1/4 minus 1. So 6 minus 1 is 5, and 3/4. So 5 3/4. Or you could say 5.75, or you could say 23 over 4. Those are all equivalent. All right. So those, we've kind of gotten through a lot of the long problems where I'm asking you to find multiple things. From here on out, I just gave you a lot of practice with word problems because that tends to be what people have the most trouble with. Do you have certain ones you want me to work out? Do you want me to try to get through all of them? What's your preference? All of them? Nobody's going to be too bored if I go through them all? Extra review is good for all of us, right? All right. What do I mean when I say an isosceles triangle? Okay. The altitude, that is the height. So that is 25. That height would form a right angle with the bottom. Each of the two equal angles. So if these sides are the same, that means these angles are the same. So these are both 17 degrees. I want to know how long the two equal sides are. All we really need is half of this. I know an angle, this is 90 degrees, this is 25, and this is x. X is across from my right angle, so that's my hypotenuse. 25 is across from the 17, so that is opposite. What trig function involves opposite and hypotenuse? So the sine of 17 degrees equals 25 over x. These are ones we can put in the calculator because they're not angles on our name trick. Okay, anytime you have a 30, 45, 60, 90, those I'm expecting exact values. But we definitely haven't memorized the sine of 17 degrees, so we're just plugging this in. The answer or the question said to use significant digits. How many were given in the problem? 2. So if I round this to 2 significant digits, we have 85.5, which is 86 centimeters. Number 21. The angle of elevation. If I say elevation or depression, what do we have to have? A horizontal line. So angle of elevation is from a horizontal up. We want to know how tall is a post that casts a shadow 1.5 feet long. Okay, so my angle from the horizontal going up was 75 degrees, 30 minutes. We want to know how tall the post is. Which side is my post? Where does the shadow go? All right, so from here, this would be my right angle. That means this is the hypotenuse. From this angle, this is opposite. 1.5 would be adjacent. What trig function involves opposite and adjacent? So the tangent, 75 degrees, 30 minutes, equals x over 1.5. So you multiply over your 1.5, and we get 5.8007. How many significant digits do we have? 2. So we would just say 5.8. Yes.
Since the numbers it gave us, one was 2 significant and another one had the 30.
You go with the smaller number. So if there's a discrepancy and you have different numbers of significant digits, always go with the least. All right. This one was probably the most challenging word problem. This one or one of the bearing ones. So we have wires on top of a tent pole. So my tent pole is 35 feet tall. The wires are anchored to the ground below the 2 stakes. The pole is perpendicular to the ground and between the 2 stakes. So perpendicular, right angle, that's between them. So that means my stakes are here and here. So the wires are going to those 2 stakes from the top of my pole. The angle of depression from the top of the pole. I'm at the top of the pole. If I say an angle of depression, what do we have to have? A horizontal line. So I need a horizontal line at the top of the pole. One of them is 47 degrees. One is 43 degrees. Those are not the angles in the triangle. Those are the angles from the horizontal line. How far apart are the 2 stakes? So I'm trying to find this distance. Is the entire thing a right triangle? No. So we have to take half of it at a time. So if I look at this one, okay, we need an angle in our triangle. Can we find an angle? Okay, which one? Okay, what do we get? 47. Those two have to add up to 90. So from here, this would be my opposite. This is the adjacent. Opposite and adjacent is, so the tangent of 47 degrees equals A over 35. Multiply over your 35. So you're typing in 35 tangent of 47. And we get 37.5329. All right, but that's not everything yet. I need the entire piece. So let's go over to the right-hand side. Let's call this B. We need this angle up here. What would it be? If you do 90 minus 47, then B is my opposite. So opposite and adjacent means tangent. So the tangent of 43 degrees equals B over 35. So again, you multiply over the 35. And you get 32.6380. So if I want the total distance, we just have to add those together. I said significant digits. There were only 2 in the problem. So when you add these, you get 70.17, so we would have to call it 70 feet. So don't be afraid to break it up and do 2 separate triangles, and then put your answers together. Any questions there? We have a bearing question. So a boat leaves the harbor entrance and travels 25 miles in the direction north 42 degrees east. You have to have a starting point. If I'm going to measure bearing, what do we need? Have to have that north-south line. And so from the starting point, we are going to go northeast. That angle is from the north-south line, 42 degrees. The captain then turns the boat 90 degrees and travels another 18 miles in the direction south 48 degrees east. Okay, so I'm giving you another bearing. You can do another north-south line because we're right here and we're measuring the bearing. And this time we're ending up southeast. We do that for 18 miles. So this angle right here is 48 degrees. We want to know how far he is from the boat or from the harbor entrance. So we are looking for this side. Now, I ignored one really important piece of information in this problem.
You turn 90 degrees.
Yes. Did I even really need this bearing? No, because I told you this whole thing is a right angle. You have two sides in a right triangle. How do you get the third? Pythagorean theorem. We don't have to use the angles at all. X is across from the hypotenuse, so that's our C. So just 25 squared plus 18 squared equals C squared. So you get 9C squared equals 949. If I said exact, you would have to break that down, but I did say significant digits, so that means in decimals. So if you do the square root of 949, it comes out to be 30.8058. How many significant digits do we have in the problem? 2. So we would round this to 31 miles. All right. Is this helping at all, guys? 4 more. Are you fixing things as we go through if you had any mistakes? 24, a road up a hill. What's a road look like if it's going up a hill? Slanted. Makes an angle of 5.1 degrees with the horizontal. So horizontal is down here. My angle is 5.1 degrees. If the road from the bottom of the hill to the top of the hill is 2.5 miles long, how high is the hill? What am I looking for here? So I want this side over here. We can assume that would be a right angle. So from there, this would have to be our hypotenuse, which means this is the opposite. Opposite and hypotenuse is sine. So the sine of 5.1 degrees equals x over 2.5. Multiply the 2.5. And we get 0.2222. How many significant digits? Or I guess I didn't say, so we can keep all of them. I didn't say you had to use significant digits. If you did, 0.22 would be fun. All right. 25. A 72.5 foot rope from the top of a circus tent pole is anchored to the ground. So we have a pole. We would assume then the pole that made a right angle with the ground, and I did tell you that later. The rope is going from the top of the pole to the ground. 43.2 feet from the bottom of the pole. So this is 43.2. What angle does the rope make with the pole? This is the rope, this is the pole. I'm looking for that angle. From here, this is across from the right angle, so that's the hypotenuse. This is across from my angle, so that's opposite. Opposite and hypotenuse. So the sine of theta equals 43.2 over 72.5. All right, so we're probably going to have one like this on the test. How do you find that angle? Mm-hmm. So that's the second sine. So that gives us 36.5 5741 degrees. If you did significant digits, it would be 36.6 degrees, so either of those is fine. The next one. I had quite a few questions about this one. So you have a tree on one side of a river, due west of a rock on the other side. What do I mean if I say due west? Straight across. So we have a tree and a rock. The tree is on the west. So here's my tree, here's my rock. From a stake 21 yards north of the rock. Here's the rock. The stake is 29 yards north. So north would be up. Ooh, that's crooked. There's my stake, and I know this is 21 yards. The bearing of the tree. How do we measure bearing? Anytime we're doing bearing, we have to have north-south line. So to get to my tree, we're going south 18.2 degrees west. So what I just gave you was this angle. How far is it from the rock to the tree? So from my angle, this would be a 90 degrees, north, south, and east, west from a right angle. So this is opposite. This one would have to be my adjacent. So opposite and adjacent is the tangent of 18.2 degrees equals x over 21. Multiply that 21 over. I get 6.9044. I said significant digits, so there were 3 in the problem, so 6.90 yards. Any other questions on that one? Final question. A boat travels on a course of bearing. So if I'm giving you bearing, we have to do our starting point, measuring bearing from there, so north-south line. North 37 degrees 10 minutes to the west. This angle. For 79.5 miles. How many miles north and how many miles west has it traveled? So what would I do? Yeah, you can just go straight across. So this is the number of miles north. This would be our west. We need to find those. From here, this would be my right angle, making this the hypotenuse. This one's touching my angle, so that's the adjacent. So this is opposite. So if I want to find my north, that's adjacent and hypotenuse, so cosine. So if we multiply over the 79.5, I didn't say you had to use significant digits, so we can keep more. So I get 63.3521 miles. If I want my west, that's opposite. I know my hypotenuse, so that would be sine 37 degrees 10 minutes equals W over 79.5. Multiply that over. You get 48.0288 miles. Do you guys have any questions? Okay, I want to talk about one thing for this test. So, the first page of your test, I'm going to make you do without a calculator. So I'm going to give you that page, and then once you finish that, I'm going to have you put it in the corner of your desk, and I am actually going to come around and grade it as you're taking your test, and then you can have your calculator after that. It is this table Does this look familiar to you? It's the one that we had like 5 of in our notes and we've practiced several times. The reason I'm going to do that is A, it's really important that you know these values. But B, if you mess up the sine of 60 degrees, I don't want you to miss that question 3 different times on your test when it pops up. Okay, so I am going to check this and mark which ones are wrong and let you keep that paper so that way you'll only miss the points one time and not over and over again if you make a mistake. You probably still have some blank ones in your notes, but I also have a stack of them up here. If anyone would like some to practice on, you're welcome to come grab 1 or 2 or whatever you want. It will be the full table. So we had a quiz one time with only sine, cosine, and tangent. All 6 trig functions will be on the test. Does anybody want a copy to practice? Just grab that test. Anyone else need one? And you cannot use a calculator when you're doing this.